Hi everybody, welcome to Unit 5, Lesson 2, Proportional Relationships. Okay, so you taught, or you, I'm sorry, you have learned about proportional relationships for a long time, okay? Probably since elementary school, right? So hopefully a lot of this will sound familiar, which is really nice, right? It's kind of a breath of fresh air. So first off, let's talk about something called fractional notation. That is a number written as a fraction. Okay, so that's easy enough, right? 1/2, 2/5, right? Those would be written in fractional notation. A ratio is a comparison of two quantities. So you're comparing quantity A to B. So 2 to 5, 2 to 7, right? Something like that. And they can be written in three different ways. You can write it with the word 2. You can use a colon, or you can write it as a fraction. A proportion is an equation where two ratios are equal to each other. Okay, so A to B is equal to C over D. All right. Something that is probably new that you are going to come up with or come to in your lesson is that the inner values in a proportion are called the means, and the outer values are called the extremes. So just keep that in mind as well. And let's get into some examples. All right, this is number 4 on your practice. It says, a company pays their employees $20 per hour. Using fractional notation, okay, so it's got to be written as fractions, write a proportion that represents how long an employee must work to make $80. Use X to represent the unknown number of hours. Okay, so there's a couple things that we can do to kind of set ourselves up for success. One really important thing about proportions is that the ratios, both ratios on both sides of the proportion, have to be balanced. They have to be set up the same way. So in this case, we have dollars per hour, which means on the other side, we need to have dollars per hour. So for this particular one, it says right here, notice we've got, they pay their employees $20 per hour. So that's the rate of pay, would be 20 over 1, dollars over hour. For every 1 hour that they work, they get $20. Well, on the other side, we need to have the dollars in the top, hours in the bottom. So we're looking for $80. Well, that's going to go in the top, and then it said to use X as the variable. Okay, so this is what number 4 is looking for. All right, all we had to do, it's not even asking us to solve. It just wanted us to write the proportion. And you might be able to see right away what it would be, right? You're like, well, I know how to get from 20 to 80. I multiply by 4, right? Excuse me. So X would be equal to 4 in this case. Okay, so not too bad, right? All right, this next one is number 5 on your practice. It says, which of the following, option 1 or 2, is a proportion? Now, you might be thinking right off the bat, you're like, they're both proportions, they're both set up as proportions. But one is true and one is not, okay? So, and there's 2 different ways that we can think about them, all right? And it's totally okay to think about them as like equivalent fractions. That's what they are, all right? So if we think about that, we can think with this first one, gosh, like I don't know how to get from 7 to 20, right? Without like doing some math. I don't know how to get from 8 to 22 without doing some math. So when we can't see it right away, the process that you can take in order to solve is called cross products or cross multiplication. So what we do is we multiply across the equal sign. So we would say 7 times 22 equals 8 times 20. If we get to the same thing on both sides, then they are proportional. Okay? So then we can think to ourselves, let's see. 80 times 20, I can figure that out. Let's see, 8 times 2 is 16, tack 0 on the back. 7 times 22, I could do it in my head, but we'll just do this, equals 154. So that tells me right away, number one is not a proportional. These are not a proportion. These do not have a proportional relationship. Now with number two, they do have a proportional relationship. And I can actually see it without even doing any like equations or solving for anything. I can look at it and think, well, to get from 7 to 21, I can multiply by 3. If these are proportional, I should be able to do the same thing in the denominator. So 8 times 3 does get me to 24, so therefore they're proportional. Now let's say you couldn't see that. Well, your fallback is going to be to do the cross multiplication or the cross products. So let's see, 7 times 24 is equal to 8 times 21. So let's look at that in here. 7 times 24, that gives me 168. And then 8 times 21, that gives me 168. Since we got the same thing on both sides, again, that proves that they're proportional. Sometimes the numbers aren't going to be super easy to see, and so that's where cross multiplication becomes a really important strategy to know. Okay, number 3, which is also number 3 on your quick check. You fill your car with 15 gallons of gas at a cost of $45. Using fractional notation, how do you write a proportion that shows how much 5 gallons of gas will cost? Use X to represent the unknown cost. Okay, so with this, let's see. In this case, we've got gallons per dollar. Like, how many gallons am I going to get per dollar? Which means that we need that on the other side as well, gallons per dollar. Well, we got 15 gallons for $45. Okay, so since I have to keep both sides balanced, on the other side I know that I have 5 gallons, so that's got to go in my numerator, and then X is going to represent the dollar amount right there. So that's what you're looking for. Okay, as always, reach out to me if you need extra support. Okay, have a great day.